Hey, this is Presh Talwalkar, and you're watching Mind Your Decisions. Oxford ranks as one of the top universities in the world. A version of this problem was used as an Oxford interview question. A ladder is placed vertically on a wall. What shape does the midpoint of the ladder trace as the ladder slides against the wall to the floor? What if the ladder instead fell backwards to the ground by rotating from its base? What shape would the midpoint of the ladder trace then? Can you figure it out? Give this problem a try, and when you're ready, keep watching the video for a solution. So how can we solve this problem? Well, it sometimes helps in problems like these to sketch out a few cases and get some intuition of what the answer might be. So let's place this ladder vertically on the wall and consider the path of its midpoint. We can imagine the ladder sliding against the wall, and we'll keep track of where the midpoint of this ladder goes. Eventually, we'll get some idea of what this path is. Now, focusing just on the midpoints, we might guess that this shape is a quarter circle. But Oxford interviews, just like my videos, are about more than getting just the correct answer. It's about demonstrating your ability to think and to prove the answer. So can we prove that the path is a quarter circle? Well, in order to do that, let's go back to our sketch and consider one position of the ladder. Let's write L for the length of the ladder. Above and below the midpoint will be L over 2, because we have half the ladder's length in each direction. Now consider these two right triangles. Because they have the same angles and their hypotenuse has the same length, these two right triangles are congruent to each other. So they will have x as their horizontal length and y as their vertical length. Now the midpoint will be x comma y in a coordinate system. Now looking at either triangle, we can use the Pythagorean theorem to get x squared plus y squared is equal to the quantity L over 2 squared. This equation is very well known. In this case, the midpoint traces out a quarter circle in the positive quadrant with a radius that's half the ladder's length. And this is the proof of why the path is a quarter circle. But there's nothing quite like seeing it for yourself. So here's an animation that I made on Desmos.com, and you can see that the midpoint of the ladder exactly traces out the path of a quarter circle as it slides against the wall. So now let's consider the second problem, which is the ladder falling away from the wall. Like before, let's sketch each of these cases and get an idea for the path of the midpoint. Now looking at this path, we might once again guess that it's a quarter circle. But can we prove it? Well, in this case, it's a little bit easier. The midpoint will always be a distance of L over 2 from the corner of the wall and the ground. So you can imagine that's the same distance and therefore it's a quarter circle. But we can also prove it like in the first case, where we use the Pythagorean theorem and we get exactly the same equations as before to show that this midpoint also traces out the path of a quarter circle. So once again, seeing is also satisfying. So here's an animation that's made with Desmos.com to show that the midpoint traces out the path of a quarter circle as the ladder falls away from the wall. And we now have a rather curious result. Both cases show the same path of the midpoint. So here's another animation that puts both ladders in the same graph, and you'll see the midpoint of each ladder is along this quarter circle. So amazingly, both cases result in the same path of a quarter circle. Now obviously in real life, the sliding ladder will be slower due to its friction against the wall and the ground. This animation is just to show why the paths of the midpoints are the same shape. A geometric way that you can see this is that the two ladders represent the diagonals of a rectangle, and they will intersect at this midpoint of the two ladders. You can also see this as the pivot point of a scissor lift. So it's quite amazing that in either case, the midpoint of the ladder is tracing out the same quarter circle. Did you figure it out? Thanks for watching. These math videos, which can be watched for free on YouTube, inspire and build confidence for people around the world, and they have over 100 million views. Please subscribe for free to get the newest videos and email me a puzzle or math topic, presh@mindyourdecisions.com. If you so choose, you can check out my merchandise on Teespring. You can check out my books, which are listed in the video description, and you can support me on Patreon for exclusive rewards. Thanks for watching, and thanks for your support.